Okay, coming to alloys. So alloys, again, this is also something that you have learnt in your school, that you mix metals, then you get alloys. Okay, officially how I would define it is, these are solid solutions. Solid solutions. Solid solutions mean they are a mixture. Metals are not, if there are two or more metals, they are not really forming a chemical bond with each other. These are still mixtures, but they are mixtures within solids. So the atoms of metal A will sit inside the metal B atoms, and they will ultimately form a crystalline structure, maybe a different type of crystal structure. Okay, so here you can see blue and black atoms. Now in this particular case I have shown blue and black to be of exact same size, but they are sometimes very close to each other in terms of size, and some metals can have very different sizes. So one metal atom is very big and the other one is very small. There may be not just two but more than two, even up to 10 metals or more metals. The idea of alloy is that you have this kind of solid solution where you can very nicely fit one atom inside the crystal structure of the other metal. So it will replace one atom of the existing metal crystal and then place itself. And this also happens in a very ordered fashion. And that is when we call them alloys. Okay. Do they always have to be metals? Well, at least the primary material needs to be metal. And that's why I have written the first one. Primary element needs to be a metal. The second one can be also carbon, for example. Carbon is a non-metal element, but that is used in a lot of alloys. Steel is a very good example. So they can also be non-metallic elements, but as long as the primary, the base material is a metal, you still call it an alloy. And again, remember, that doesn't have to be just two. There can be also multiple elements involved this way. So these are your alloys. Okay, why do we make alloys? Okay, we make alloys to improve upon the properties of an existing metal. What do I mean by improving the properties? You can improve properties in various ways. You can improve thermal properties. You can improve mechanical strength. You can also, also melting point can be changed, and also physical properties, resistance to corrosion. There are all these things that you can do, which maybe these properties are not present in the metal, but you just sort of tune its properties a little bit and you get these improved properties, and that is the reason we make alloys in the first place. Okay, but alloys, I am talking about alloys now in the same lecture as metals, because the overall properties, given the base material is still metal, the overall properties of alloy are similar to those of metals, in the sense that they can also be melted. You can also make thin sheets out of them. You can also pull wires out. So most of the alloys have properties that are very similar to those of metals in terms of manufacturing, in terms of processing. Okay, and that is why we are putting metals and alloys pretty much together in the same class of materials, rather than plastic, polymers, ceramics. They will have completely different set of properties. Metals and alloys are very similar in that sense. Also, most alloys are also lustrous. Okay, so, and this is something you know already, they are mixtures, they are not a compound. Okay, fine. So I was talking about improving the properties. Here I have written the same. You have, you can improve or increase resistance to oxidation by alloying. You can also increase the melting point. Sometimes increasing the melting point is also important or necessary for certain processes. Sometimes you can increase the mechanical strength and so on. So this is why we perform alloying. So this is one picture here where you can see an alloy on the rim of this wheel. This is also one of the very old wheels. Okay, fine. Now, should we, if we are making an alloy out of two metals, let's say, or two elements, then do we always have the exact same fraction, like 80-20 or 90-10 or whatever is the fraction of each element in that alloy? Does it have to be always that, or can it change? Well, that depends. In some cases, the ratio is fixed, and in some cases, the ratio can be tuned. So, for example, if you mix gold and silver, in that case, you have a little bit of flexibility of how much gold and silver you want. So, if it can be 50-50, it can be 60-40 as well. But in certain cases, for example, Ti2Si, which I have written here. This is an alloy of titanium and silicon. In this particular case, the ratio is fixed, and there are many examples where ratio is fixed. Okay, so this was about alloy. There's something also called super alloy. So what is so super about it? Super alloys will have these very interesting, specialized, high performance. And when I say high performance, again, what does that mean? Good performance in terms of, for example, thermal properties. So they may have very high melting points, and if something has very high melting point, I can use it for applications where I need to use, let's say, 2000 degrees centigrade temperatures. These materials also have resistance to corrosion, so I can use them at high temperatures in the presence of oxygen, and they might not oxidize. So these alloys, they are very specifically designed, and they have not one or two but up to 10 metals involved in it. And there is a range of such materials. They are known as super alloys. Super alloys will not form a part of this particular course. We will just be dealing with simple metals or steels mostly in your workshop. Okay, so super alloys, there one example I have written, Inconel 718. These are the commercial names, and these are very, very specialized materials. Okay, so in the previous lecture I had also mentioned that we classify metals and alloys between ferrous and non-ferrous. The reason being, iron has been the most common manufacturing materials. So this is, now let me see. So ferrous means iron based, and non-ferrous means not iron based. But that does not mean that ferrous means 100% iron. It means mostly the highest fraction is iron. So for example, steel is also a ferrous material, despite the fact that it does contain a carbon, sometimes also chromium and so on. But these are ferrous alloys because the base material is iron. Non-ferrous, of course, does not contain, in most cases, does not contain any iron. But if you have 1% iron, that's acceptable. It is not the base material. So copper wires, if you think of, they are just copper. Or if you are thinking of any alloy, brass is one example where you don't have iron. Or in some alloys you can have very little iron, but it's not really the base material. So we have ferrous and non-ferrous alloys and metals that are used for manufacturing purposes. Why? Iron is also a very easily available metal, which was also in the past available pretty much all over the world, and it can also easily be processed, and that is why people started their manufacturing. With copper also, iron had relatively higher mechanical strength, so this has been a material which is used for a very, very long time. This also means that when the Industrial Revolution started, and when the manufacturing was taken to industry rather than doing it by hand manually. So at that time also, initially a lot of processing equipment were actually designed for processing iron. So basically this material also has a lot of sort of compatibility with the manufacturing equipment, and that is why now, of course, from iron we moved on to many other alloys and other metals as well, which are of similar type in when it comes to their processing. But iron still remains very important. That is why ferrous non-ferrous is an important classification. Now, some other properties of iron, that iron is magnetic, ferromagnetic. The alloys made of iron are not ferromagnetic, but they do have some, magnetic properties. They often show some magnetic properties, and that is why you can use steel pots on induction plate, cooking plate, right? So they do have some magnetic property. Non-ferrous alloys, on the other hand, generally do not have magnetic properties. Of course, other than iron, nickel and cobalt also show some magnetism. So depending upon what type of alloy you're using, you can use them either for magnetic applications or not. This is a picture of one good old-fashioned train where everything was made of metal. In this particular case, mainly that of iron. Okay. What else? So we talked about ferrous, non-ferrous materials. Now we also talk about something known as refractory metals. In this particular case, we are talking about metals and alloys, but refractory materials there's several ceramics, in fact, that are also refractory. What does that mean? refraction, don't relate this to refraction because the optical refraction, that is different, right? Refractory material in manufacturing applications are the materials that can withstand a lot of heat without being deformed. So they can be used, for example, for making molds in which you pour the boiling hot metal. So your mold itself should not get damaged, right, when you pour boiling hot metal in it. So those materials which can be used for mold making, they are known as refractory material. Their important property is that they can withstand very high temperatures. Now, some of the metals are also refractory. They can be used as refractory materials, and there are some examples. Yes, I have written some examples here. So some metals and some alloys can also be used as refractory materials. They also have high, so number one, they do not deform at high temperature. They also have high wear resistance. And what is wear? Wear is basically damage over long periods of time. So these are some of the properties of refractory metals, and we will discuss this further when we talk about ceramics. Okay,